Hi students, today I will explain how to calculate area of a triangle when vertices are given. See, the area of a triangle when vertices are given. Capital A, x1, y1, capital B, x2, y2, capital C, x3, y3. Here, this is coordinate axis. Here, I will take A point x1, y1. Here, I will take B point x2, y2. Here, C, that is x3, y3. These three not lying on the same line. These three forms a triangle. Our aim is to calculate area of this triangle. Now, this is positive x-axis. This is negative x-axis. Here, negative y-axis, positive y-axis. This is origin. Here, draw perpendicular from A to x-axis. That is, I will take L. Because it lies on x-axis, its coordinates x1, 0. Here, take projection of B on x-axis, take that as M. Here, on x-axis, there is no y. That's why y coordinate 0. Here, take N as projection of C on x-axis. Here, coordinates of N, x3, 0. Now, area of triangle ABC is equals to, here, area of triangle ABC is equals to, see, here, area of this trapezium, area of trapezium, area of ABML, ABML plus area of this trapezium ALNC, ALNC minus, here if we delete this area, if we remove this area from these two added areas, then we'll get area of this triangle minus area of trapezium BMNC, BMNC. Now, what is area of trapezium ABMLC? Half into sum of the parallel side. Here BM distance is y2. Here x2 minus x2 0, y2 minus 0 whole square under square root. Distance between 2 points. Here AL distance is y1. That means half into y1 plus y2 sum of the parallel sides into this height distance between these parallel sides x1 minus x2 plus half into area of this trapezium. Here distance between parallel lines, sum of the distance, sum of the parallel sides, that means y1, this is y3, y1 plus y3 into distance between these two parallel sides x3 minus x1, x3 minus x1 minus half times, here area of this trapezium, that is BMNC, that is parallel distances y2 plus y3 into distance between these m and n, that is x3 minus x2. Now everywhere half is there, and simplify x1 y1 minus x2 y2 minus y1 x2 minus plus x1 y2 plus x1 y2. Next, y1 x3 plus y1 x3 minus x1 y1. Next, plus x3 y3 minus y3 x1. Now it is minus of times. Here minus x3 y2 minus x3 y3 minus into minus plus x2 y2 plus x2 y3. Now whatever terms gets cancelled, we will cancel. x1 y1 gets cancelled. Here x3 y3 positive, here negative, gets cancelled. Next x2 y2 positive here, x2 y2 negative here. This becomes half times. Here whatever terms left out, take x1 common. If I take x1 common, y2 minus y3. Take x2 common, what you will get, check. x2 common, then here x2 y2 positive, here x2 y2, this is positive, not this one. This is x2 y1. We will check. This is x1 y1 minus x2 y2. Next minus x2 y1 x1 y2. Okay, now x2 gets common, then what we will get, x2, wherever x2 is there, check. X2 y3 minus y1 plus x3 gets common, y1 minus y2. This is, these are six terms. See, 1 2 3 4 5 6. This is area of the triangle. Because area of the triangle is non-negative, that's why we need to take positive. Here this is half into modulus of x1 into y1 minus y2 plus x2 into y3 minus y1 plus x3 into y1 minus y2. This is area of the triangle when vertices are given. Now we will check what are the, this only can be represented in many ways. I will write all those ways. Here this can be written as absolute value of half times determinant of x1 y1 1, x2 y2 1, x3 y3 1. This is one way of representing this one. This is absolute value, means always positive. Half times in between two parallel lines, rectangular array, that is called determinant. Here square units. This is same as absolute value of half times, here x1 x2 x3 x1 y1 y2 y3 y1. This is same as absolute value of half times x1 y1 x2 y2 x3 y3 x1 y1. This is vertical representation called ladder formula. This is horizontal representation, and I will use in general, for me convenient formula is half times x1 minus x2 x1 minus x3 y1 minus y2 y1 minus y3. I will use this formula, absolute value of half times. This is convenient for me and easy to remember. If I remember 12, 13 two numbers, x1 minus x2, x1 minus x3, y1 minus y2, y1 minus y3. And to get area of any polygon, just we will extend this formula. Here, if we need area of quadrilateral, then what we will write? Absolute value of half times x1, x2, x3, x4, x1, y1, y2, y3, y4, y1. How to simplify this one? Whenever you are coming to down, take positive x1, y2. See here, this one x1, y2. You will get this. Whenever you will go upwards, y1, x2, take negative x1, y2 minus x2, y1. This one x2, y3 minus y2, x3. This one x3, y1 minus x1, y3. Here, this is called determinant. If you write in modulus one single term, this is called in between two parallel lines, one numerical. This is called modulus or absolute value. These are rectangular arrays. These in between these two parallel lines, you are making one rectangular array. This is called determinant. That's why I written absolute value. Okay, guys, thank you.